I was really looking forward to following Professor Plun's, because so much of what we're dealing with now is much larger than how do we design a building or even how to save a little bit of energy. And one of the heroes of the green movement in the United States is a gentleman named Ray Anderson, who we just lost. He founded a company called Interface Carpet, and he was a great kind of Southern Baptist preacher, and he said, Rick, never forget, every person only has exactly one story to tell, which is their own. So I'll go pretty quickly and tell you about my story, how I came to this. My first green building was a building called the Center for Wellbeing out in East Hampton. And it was founded by the gentleman who put together the Time Warner merger, Stephen Ross. And he thought that Americans and the first world would lose their advantage because of our Eurocentric and Western-centric education. And that he set out to create global citizens who would be fusing Eastern and Western concepts of health, fitness, and education, that we were going to lose our advantage. He saw the rise of the East and the fall of the West if we continued to educate our children the same way. So my very first green building had this background behind it. And I'm a kid from upstate New York on the Hudson Valley that Professor Plun's just spoke about. And it really brings up the issue about what is this green stuff, the sustainable design, and what the heck are the Americans doing talking about it now? Most of the Europeans had been way ahead. So we're best known for a building called the Bank of America Tower at 1 Bryant Park, the one that you see here. We were blessed with the opportunity of designing it for the same family who built and developed this building called 4 Times Square, which was the first green skyscraper. Well, this really brings us back. There are those of us from upstate New York who say the green movement started there. And the reason that I say that is that this is way beyond saving energy or carbon footprint. It's about thinking for the next generations. And the Haudenosaunee people, the people who build longhouses that I grew up calling the Iroquois Confederacy, in 1142 gathered together, and they were the first participatory democracy in the New World. In 1142, if you think about that, those of us of common heritage, what we were living in 1142. In 1142, they elected, the women elected representatives to go to the council fire and review issues of common importance. They elected one male figure to go to the council fire in central New York. And at that Congress, they agreed that they would, in their every deliberation, consider the impact on our decisions on the next 7 generations. And that's where this product line called 7 Generations comes from. But I think the importance there is you may see that, you will probably see your next generation, you'll see your grandchildren, you may even see your great-grandchildren. A few rare people might even see great-great-grandchildren. Nobody sees the 7th generation. So are you planning for this legacy? Are you thinking long-term? And for me, that's really the definition of sustainability. We started out designing this building in 2003, 2004. Number one question we were asked every place we went was, how much more does this green design cost? And at that time, we were trying to get the point out about climate change and global warming, which has become commonplace. Even the Bush administration accepted the IPCC climate change report. So that was a big turning point. We call it May 2006, when Vanity Fair comes out with their green issue. We decided that we could stop talking about these issues, but we love this image that came out in Vanity Fair of what happens if the climate scientists are right. We're dealing with a really compelling need to address this. Is it going to be adaptation? Is it going to be suffering? Is it mitigation? Are we going to deal with mitigation? René Dubos in 1972 was working for the UN, and he coined a term that I grew up with. It was think globally, act locally. And so we had this opportunity in this context of thought that we had a chance to act locally. What you're looking at here is 42nd Street, this is 6th Avenue, Bryant Park, New York Public Library, Times Square, 4 Times Square, the first green skyscraper in New York, and the site that we had the opportunity to design a building on. For us, it's important, what's the sense of place? Whatever happened here before? This is 6th Avenue, that's 5th Avenue, and this is 42nd Street in 1855. What we're looking at here, where the New York Public Library is now, is the Croton Reservoir. Dr. Plun's just spoke about the water infrastructure that previous generations invested in so that New York City has one of the best drinking water supply systems. We take it for granted. Most of the world views potable drinking water as a precious resource. We've been able to squander that in New York just because previous generations have supplied us so well. Behind that, what used to be called Reservoir Park and is now Bryant Park, we built the exhibition for the industry of all nations after Paxton's Crystal Palace in London in 1851. Mark Twain said of this building, beautiful beyond description. You can see that the world of Manhattan was dense masonry buildings. The Reservoir was this Egyptian dense masonry building. And this is this first light, airy, glassy building. You'll hear from James Carpenter right after me, who will talk more about the beauty of glass. This is a close-up of the building, and this is the very first metal frame, all-glass building in New York City. They even toyed with ideas of how to cut back on the solar heat gain. They baked porcelains on the glass to cut down on the heat gain. And inside of that building, right here, this little guy is Alicia Graves Otis, as in Otis Elevator. And Alicia Graves Otis, they cut the cable, his safety brake locks in, and he says, voila, I didn't die in the crash. And this, in 1855, he displays the safety brake. Many scholars consider this the tipping point of the high-rise age. We knew how to make buildings tall. We didn't know how to get people up and down in them safely. So right across the street is this Crystal Palace from the site that we have the opportunity to work on. And we were thinking more about crystals. We believe that people feel good and like things that they think could be found in nature or follow natural patterns of nature. This happens to be a crystal from the Durst family collection. We were looking at this as we were designing the building. And that's the building on the Skyline now. The facets on the building were primarily driven by looking around the buildings. The cereal boxes around it were primarily driven by that, by the views looking out, but creates this kind of crystalline form on the Skyline. But for us, one of the things that was more compelling, and I'll talk about that a little bit later, was how the building connects to the street. So this is the corner of 42nd and 6th. I think you're going there today. The connection to mass transit. When I speak about this building in some place like Florida, I say 2.2 million square feet, not a single parking spot, not even one for Mr. Durst. And in Florida, there's an audible gasp, like, you know, where was everybody going to park? We did a calculation. If this building had parking according to typical American planning criteria, we would need a parking garage 8 stories tall covering entire Bryant Park, which is the front yard for this building. Okay. We're very interested in how people do connect with nature, and this big glassy building, it was important to us how people actually touch the building. The first time they touch the building is a wood door handle, and you'll see that when you're there. Your overhead is a bamboo canopy, gathering the space out over the sidewalk and creating these oculuses. Each one of them at 12 o'clock, if you stand there, will frame the sun at the solstices and the equinoxes. And that's the building as it exists now. There's green roofs out on this podium roof looking back to Times Square. We have Bryant Park as the front yard, and the building's tall enough to be looking out into the horizon, connecting with sun and sky. So why do I get asked to speak at events like this? It had to do with fundamentally rethinking how we're going to build a skyscraper. We did not start by chasing after a LEED rating. That was never in the discussion. It was, how do we fundamentally rethink how we build buildings in America? So we had the incredible blessing of being able to study every technology that was available at the time. We looked at wind. We studied wind turbine technologies. None of them really paid for themselves. Obviously, the sun is both a way to harvest energy. The building next door had photovoltaics. There are no photovoltaics on the Bank of America Tower. Rain became extremely important as a resource for fresh water. Bioprocesses, biodigesters, methane capture. A banking institution has a tremendous amount of food waste and paper waste. So that was one of the things that we'd studied and went very, very far. In fact, one of the problems we had is the chain of command of banking records. We could not get a biodigester approved as one of the approved methods of disposing of financial records. And then the earth as a heat sink. We also knew, although not free, we knew that because it was a project of scale, we could implement something called cogeneration or on-site power generation. I'll explain why in New York City that was so important to this project. First of all, most important thing, yes, LEED Platinum. If this was just a code building on this site, it would be fundamentally greener than a LEED Platinum building in the suburbs. Okay, so right now, the greenest building by performance standards is the NREL headquarters. It has a 1,800 car parking garage. So the issue is, how do people get to work? We are blessed with a remarkable mass transit infrastructure system here, unlike a typical American city. So we did the calculations about if this was a suburban office complex versus urban. Because of how people get to work, the overall energy use would be 1/20th of a suburban campus because of the carbon footprint and the energy use of how people would get to work if they drove. So the answer is in urban density. We have no question about this. And we're seeing that the world is urbanizing very rapidly. Each of us just lived through the change from a primarily rural planet to a primarily urban planet, and that's continuing very rapidly. New York City subway car gets 540 passenger miles per gallon. I have a hybrid vehicle. It is not the answer. Mass transit is the answer. So connecting to mass transit, I'll go quickly. I know you're running a little bit late, but we have 1.4 billion rider trips in our subway system. For an American city, that's just remarkable. For European cities have understood that the real answer for urban density and high quality of life is mass transit. In most of the United States, we're having a really hard time. The project was large enough to connect the BD, V, and F with the Times Square stop and make this underground connection for the first time. In fact, we're waiting for the MTA to fund the connection, the rest of the connection. 4 Times Square did nothing with water. So we talked about, Professor Plunz talked about the water infrastructure and how well supplied we are. But the other side of it is really unbelievably stupid. We combine raw sewage and stormwater runoff into water treatment plants, and we pump treated water out into our rivers. Okay, that's fine. In some places in the city, as little as 1/10 of an inch of rain overflows our combined storm sewer, and we pump raw sewage directly into our rivers. Just unbelievably bad and stupid, and we must change this. So how do you change it on a building? Collect all the water? You can. We get about 48 inches of rain in New York City. We don't think of it as a particularly wet climate, but we get about 48 inches of rain in New York City annually. So we had 2 acres in the middle of Manhattan, and we set out to collect every drop of water that was technically feasible. And the way we did that was in a series of storage tanks, and we stored them at different heights in the building. So one of the advantages of skyscrapers is we have gravity pressure to reduce pumping energy, and also down at the base of the building. The dirty secret about modern office buildings is we cool them by sweating. We use something called cooling towers, evaporative cooling towers. We make buildings sweat, and we use enormous quantities of water cooling buildings. So by collecting all this water, about 300,000 gallons of storage downstairs, we're using that water to run the cooling towers. It's what's called cooling tower makeup, as well as flushing the toilets and other uses. So I never thought I would stand up as a designer and talk about urinals. But my partner said, no, Rick, you have to wrap your mind around this, how much water is used in urinals. So we have 54 floors, we have thousands of people working in the building, and so I was really embarrassed about the whole thing. And so I sat down, literally on the back of a napkin, I wrote out the calculation on how much water could be saved. And I had to check it because it came up with 3 million gallons of water by changing from conventional code-complying urinals to waterless urinals. 3 million gallons of water a year. So before my partner banned all these little 1-liter water bottles from our office, we always had them around. So I was saying, how do you tell people what 3 million gallons is? So if you take these, it's 22 million of these. 22 million of these. So we're like, well, okay, how are we going to tell people what 22 million is? It's 2,929 miles of these end to end, enough to stretch from where we're standing right here to San Diego, California, of these bottles, straight end to end, every single year by changing one technology in one building. We must change the way that we think about water in our developed cities. Okay. So back to my more comfort zone. We like to look at artists. We think artists see things before scientists. I'm a designer, I can't help it. And so I think scientists sometimes see things and they get the idea across better than anybody else. So this is an artist named Richard Box in the UK. He installed 1,301 fluorescent tubes into the ground, no wires. All of those are lit by the stray current off of these. Right? So again, not being a scientist, what I say is, I don't know what it means, but it can't be good. I've seen dairy cows, I've seen children's playgrounds close to these, and it brings up another issue, is because of our distribution network here and most of the developed world, we lose a tremendous amount of power and transmission loss. In the US, they use 7% transmission loss as a quick lingo on how much power is lost when we're transmitting from central generation to point of use. And why should we really care about that? There's another issue directly related to that, which is peaking. We have a very peaky energy profile in New York City because office buildings have a very peaky energy profile. We have a term for our dirtiest power plants, which are called peaker power plants. We've actually done a pretty good job cleaning up our energy infrastructure, but we do not turn any of our old dirty plants away. We have them sit there, and the terminology for them are peaker plants. You may be very familiar with this, but they tend to be multiples dirtier. So the statistic is 90% of the smog in New York City is produced by 50% of the power plants. That's how much better and how much worse our power infrastructure is here. So what can one office building do about this? This is why we get beautiful sunsets over New Jersey, by the way. This is a very peaky profile. This is a diagram of a profile. So a typical office building has a base load and has a cooling load. Think of it as 3 o'clock on August 14th when we had our blackout a few years ago. The idea is to flatten that out. And how we pay for this is we have demand charges here. You pay based upon your demand because Con Edison has to supply the infrastructure to hit that peak load, and they charge you a different rate than if you have a lower peak load. So the goal for an office building financially is to flatten this thing out as much as possible, and one of the ways we do that is on-site power generation and then ice making. So this is quickly a diagram between a conventional building. In New York City, right now plugged in, we're using about 27% efficient power. We've lost about 2/3 up the smokestack, the 7% transmission losses. You end up with about 27% efficient power in New York City. It's remarkable. If you have hydropower and with the nukes, it changes everything. But with, in New York City right now, when this thing's plugged in, we're using about 27% efficient energy. So by doing on-site power generation, we have a 4.6 megawatt gas-fired turbine producing energy on-site with heat capture on the other side. And we're getting about 77% efficiency. So that's changing our carbon footprint and energy profile, but most importantly, the financial attributes of it are fundamentally different because it clips we call it clip shaving, peak clipping, and that cogeneration facility, that gas turbine produces more energy at night than the building uses. So what we do is we have 44 of these 10-foot diameter tanks in the basement filled with water. We make giant ice cubes at night, 44 enormous ice cubes at night. And what that does is we're using the cogen to power a chiller, a low temperature chiller, and we're freezing the tanks. And what that does is allow us to melt that ice to clip the peak at the right time. It really doesn't save any energy. In fact, from a pure engineering point of view, it uses a little bit more energy because of the conversion, but it saves a tremendous amount of money and potentially back to our carbon footprint and pollutants because of the time of use. Time of use is a really important issue in New York City. I'll go over this pretty quick. The other, David, did you have a question? Yeah.
I'm not sure everybody got the last one about ice cube and how it functions.
Okay, sure. I'm an extrovert, so ask questions. So we have giant 10-foot stainless steel tanks. Inside of it is plexiglass, plastic tubing in giant mats, and they run it around. We use a chiller, an absorption chiller, to produce very cold chilled water. That chilled water runs through this tank. It's filled up to about here with regular old tap water. that freezes each one of these. They're down in the basement. There's 44 of them. It freezes that into a giant block of ice. So at night, we're producing the energy off the cogen. We're doing electric drive chillers, making the chilled water, which freezes the domestic water. Then during the day, we have a stored capacity of cold, and we run the system in reverse to cool down our system as opposed to running chillers. So it's really just, it's a time lag issue because the cost of energy at peak load in the daytime is so much more than at night. Did that make sense? Okay. I'll go by this one pretty quick. If the gypsum manufacturing and cement manufacturing globally are huge carbon. The one that's easy, I'm an architect, so it's hard to remember a lot of things, but 1 ton of cement, we produce 1 ton of CO2 in the atmosphere. We've made great inroads in New York doing cement substitutes. Our building uses 45% blast furnace slag. All the concrete in the building is 45% blast furnace slag. Reduces about 25,560 tons of CO2 from that one change. That was really pioneered down in Battery Park City. The Bank of America did it. And right now we can get 45 or 50% blast furnace slag cement substitute on any building in New York at no additional cost. Marketplace transformation is a really important concept that I'd love to talk about, but I'm sure I'm going to run out of time.
No, but it's okay. I think you're doing very well.
Okay. Thank you. The other thing is, it was really important for me to convey is that, yes, although this is the first LEED Platinum skyscraper, we're never chasing LEED points. It was about changing the way we build buildings. So for 1 point under this rating system by the US Green Building Council, if we recycle 50% of the construction debris, that's 1 point. If we recycle 75%, that's 2 points. So, but when you set out to try to do the right thing, you can go far beyond that. So on one hand, we got to 91%, which is nice. But more importantly than that, if we had crushed up all these pallets and the big spools that wires come on, you know, imagine how many miles, thousands of miles of wire go into a modern skyscraper. Those spools were around. They normally get thrown in a container of wood that gets recycled as wood and it counts. But it doesn't make any sense because pallets can go back as pallets, spools can go back to spools, but in New York City, space is the premium. And it took somebody like the Durst family to tell the construction manager, make space so that we'll get a tractor trailer truck to come back, pick up the pallets and take it away. In New York City, speed is everything, speed of construction. Quality of construction isn't our strong suit in New York City, but speed of construction is. So anything that holds up the process is the enemy of the New York City construction manager. But anyway, it took the commitment of the Durst family to get that done. Okay. So all of that said, we save about half the amount of water that a building of this type would use with a MEC code. We save about half the cost of energy that a building like this would. We were not able to change the bank's energy profile, and this is very important as we move into the next. At that time, in 2004, we were just trying to change the building. That's why we generated power on site that was more efficient, because the banks are banks. We all use these things. We all use computers. The energy profile keeps on going up. We all want more power and more speed. It takes more energy. So the way to pay for all this stuff was actually in people. Energy is a very small sliver. This is a study done by Rocky Mountain Institute about a typical American service business. Okay? Energy is that little tiny sliver right there. The blue are people and their benefits. So if we cut that in half, we've made almost no difference to the bottom line. But if we can change health and productivity just a little bit, even insurance costs are way more than energy. So we cut the energy cost in half. It was about, in 2004 dollars, it was about $3 or $4 million. And this is before everybody hated our banks. And they were paying bond traders $3 or $4 million. 28-year-old bond trader was getting a $3 million bonus. So it really wasn't getting anybody's attention. When we talked about attracting the best talent and retaining the best talent, people were really paying attention. So we started to focus in on this. How do you change human health and productivity? And the calculation is that if we change productivity just 1%, it's worth 3 times radically changing the energy profile on a financial basis. So what's 1%? 1% is 5 minutes in a typical work week. So how could you get 5 minutes a day in a typical work week? So one was bring the best quality air indoors that you possibly could at any building that's ever been built for the office market. 95% particulate filtration. At the top of the building, there are air filters the size of this room that suck in the air at the top and provide outdoor air, heavily filtered, 95% particulate, plus gas phase filtration also. So supply the best quality air you possibly could, way cleaner than if we open the window. The other one is how do we get the air there? Most American office buildings have overhead air distribution that comes in very cold and mixes the air. Also mixes dust, pollen, the sneeze of the person next to you. So, and the #1 complaint in every office building in America, far and away, is I'm too hot, I'm too cold. It has to do with human perception. So you see the people with the sweaters here, you see the person in the Bermuda shorts there. You see we typically have these, this is a Honeywell device that is in, was in all of our lives. You see the lockbox on top of it, or it's that thing is always in the corner office where the boss has it, so he gets to keep the temperature they want. So we did underfloor air with swirl diffusers, like in a car, allow people to adjust their environment, and we did underfloor air distribution. So now we're able to bring the air in at 10 degrees warmer, and we're able to deliver it to people. Why does this help? Hot air rises, we're hot, our computers are hot, so we're in a plume of air that's moving up. We use displacement air, much less pressure, and the whole floor is a giant duct. And coming out of that swirl diffuser, it allows people to adjust it. And one of the things that's kind of funny is that, one, we did not get this approved by its green or its comfort. What the bank came back to us, and this is a major decision because all the elevators and stairs get set higher. Nobody had ever done an entire skyscraper in America with raised floor installation, although it had been done in European cities. And they came back to us and they said, Bob, Rick, you guys can tell people whatever you want about why we approved the underfloor air, but I'll tell you why it actually got approved if you want to know. And so we're like, yeah, sure. And he said, it's called churn rate. The bank churns offices at the rate of 10 to 15% of their office space annually. In fact, many offices changed before we built them, and before they even moved in, they churned because of restructuring in their corporate environment. And it's much less expensive to move partitions around than it is to move ductwork overhead. So they calculated this is a much more cost-effective way for them to have occupancy of this building in the long term. The other thing that's kind of interesting is that in anecdotal evidence, people like it because they know they could change the swirl diffuser. I've asked many people, like, do you like that? And they're like, oh yeah, it's great. I said, have you ever changed it? And they're like, no, I'm too lazy, but I know I could. Instead of waiting for somebody else to change their environment, they know that they're in control of it, and it seems to cause a perception of comfort and satisfaction that isn't directly related to actually changing their quantifiable results. Okay. People are hard to study. Also, a big issue is connection to daylight. So we paid an enormous energy penalty on the heat loss side because we wanted connection to nature. So we have floor-to-ceiling glass. The heating element is below the raised floor. So we have floor-to-ceiling glass. Why did we do that? Because it feels fantastic, and people react really well to daylight. So if you're going to do this, you need to do daylight dimming, and you need to do glass partitions on the interior so you're bouncing light very deeply into the interior. And you need to do daylight dimming so you're harvesting that daylight. We waste an enormous amount of energy by leaving lights on like this when it's plenty light enough with natural light. Okay, and then what we did on the outside is we used the clearest glass that was commercially available, which is, the lingo is low iron in the US. We used a low E coating, the clearest low E coating that was commercially available at the time, and we did something called a ceramic frit on the glass, tiny, tiny little ceramic white dots on the outside. So this fog that you see here on the outside, your eye reads right by it from the inside. You can just see it in this view, but your eye reads right around the dot. To the sun, those are opaque and reflect the sun. So I asked Douglas Durst after he moved in on the 49th floor, so second generation green skyscraper builder. I asked him what his favorite green feature of the building was, and he said the view. So I think this is an important point though. People feel good when they feel connected to nature. So I'll change scales completely. We are very encouraged that by being involved in the green movement, we get to meet some really interesting people. And this is a photograph by a photographer named Kenro Izu. And he asked us to help him with healthcare in the developing world. So the issue is that in 2004, China urbanized at the rate of 15 million people in 1 year. So New York City at 8 million, 7.5 million. So 2 New York cities moved from the countryside to the city in 1 year. The Earth has never seen anything like this. So this rapid urbanization, and how could we possibly deny the developing world the same things, access to good health care that we've grown up with? How could we possibly say, you guys have to slow down because we don't want you to mess up our quality of life? I don't know how in good conscience we can look our fellow global citizens in the eyes and tell them that they need to cap their carbon because we've been enjoying it for our lifetime. So we got to go to Cambodia, which is a tiny little country, happened to deal with a horrific genocide. I went there with this idea. We're an adoptive family. Our boys are Khmer by birth, and this is on the way to pick up our boys at this orphanage in the background, this little Western orphanage in the background. And this is out of a tour bus with other adoptive parents. And I looked out and I said, that's what I'm talking about. The developing world can get it right. They already have it right. It's air-cooled, rainwater collection, shaded porch, connection to nature. That's a little primitive hut. That's nirvana right there. So I said, you know, they know things we've forgotten. But at the other side of that same tour bus, the exact same moment out the other side, this is out the other side of that tour bus, choking congestion, unrefined petroleum sold out of little 1 liter bottles on the side of the road, horrific pollution, and rapid urbanization. So how are we going to deal with this? This is our little building under construction in Siem Reap. It's an addition to the Siem Reap Children's Hospital, the Angkor Hospital for Children, which is considered the best child care hospital in Cambodia. So we had the chance to work on this. This is a real labor of love, and it was at that time attributed as the first green building in Cambodia, and it became clear that it made no sense for people to send their money to take care of the children's health care while firing up diesel-powered gensets to provide the power, because the energy infrastructure is horrific and completely unreliable. You can't run a hospital off the energy infrastructure. So we had to generate our own energy. So that brought up, this is the building now on the streets of Siem Reap. If you're there going to the Angkor Wat Temple complex, you can go by it day and night. It was intended to be very transparent buildings. So during the daytime, the louvers shade it, so when you're inside watching the people come and go from the hospital, you're kind of not on display. And at night, when everybody goes to sleep in the hospital, the building glows, and it's kind of a showpiece for the things that were done. Kenro Izo said that when he takes his pictures, he captures a sense of a place, that he captures the love of the place. And he couldn't sell his pictures because of the horror that he had seen there. So he sold his pictures, raised the money. He raised $30,000. 2 of his friends gave him $30,000, and with that seed money, he started a hospital there. And his point was that every single one of us, he's just a photographer and artist, but he started a hospital. Every single person can make a difference in the world. You just have to have your heart in the right place and set out and do it. So this project led to something called Naga Biofuels. This is how architects kind of go off on wild tangents. I got really, really interested in a plant called Jatropha curcas in Cambodia. It's called Lahang Quang. It's a high nut oil plant that they burn some places in Africa as a candle, as a lantern oil. It grows in depleted soils. We planted a foundation. Our refinery got caught in customs. The guy who was running the plantation took off with our stuff. It was just a story in how projects could go horribly wrong. But what happened was there was a new waste product in Cambodia, and that was waste vegetable oil that never existed. There was essentially, in very poor countries, there's very, very little waste because everything has value. So we had waste vegetable oil, and we changed the whole project from Jatropha curcas refinery to a waste vegetable oil refinery. And this is our refinery after we got it out of customs, which was another whole long story, the tyranny of distance and language and working in the developing world. and we're now producing about 14,000 liters of clean biodiesel, producing all the power for the Angkor Hospital for Children, the Prince Sihanouk Hospital Center of Hope, which is the best adult care, and several other not-for-profits and orphanages in Cambodia. And the crazy thing is, it seems like one of the best environmental changes that it could happen is the byproduct is a high-quality glycerin, which is great for cleaning parts. And right now on the streets of Phnom Penh and Siem Reap, they clean automobile parts and motorbike parts with raw gasoline, which runs right into the storm sewer, which runs right into their water system. So we have a very high-quality glycerin parts degreaser. It's going to be on the market very soon, as soon as our labels are printed. And it looks like that might be one of our best environmental footprints, completely accidental. So as a wrap up, this is our roof here in New York City. Oh, you're coming. Okay, great. So this is 6th Avenue, the Empire State Building. This is 6th Avenue and 20th Street, and that's our roof. And the National Geographic came and saw it. They loved it. They included it in their special on green roofs. And the editor of National Geographic said this about it, which makes a point that I'd like to talk about just for a minute before I take questions. He said, here is where being responsible and attuned to the environment pairs up with spiritual satisfaction. We cannot do the things that we need to do if we're focused just on energy and carbon footprint. Human beings are very tricky. We have an innate desire to connect with nature. The terminology that we use for that is biophilia. People feel good when they feel connected to nature. I think this brings up the locavore movement, urban agriculture, reknitting our ecosystems. That little green roof, we planted ourselves with sedum. And the first summer, we dropped our roof temperature from 150 degrees Fahrenheit to 92 degrees Fahrenheit just by adding it, and the sedum were only this big. Then they started to fill out, and little bugs came, and everybody started sending emails around the office like about the little bugs and little flowers. Then we had bigger bugs following them. Then we had birds following them. And by the end of the second growing season, we had predatory birds hunting the smaller birds. We were reknitting a little piece of the ecosystem. I think the answer is in urban density, no question. But when we do that, we can't isolate people from nature. It's where we feel good. It's where we're at our best. So I think the other issues of urban agriculture, biophilia is the terminology that we use, are very, very important as we plan for a green and sustainable future. And we must not move our food all around the planet just because we can. I think we need to start looking at our food structure as being much more localized. As you probably got the idea, I could talk for a long time about this topic, but I wanted to say thank you and leave you with one thought. E.O. Wilson, who is one of the greatest heroes of the green movement globally, he's a biologist from Harvard. He's the world's expert on ants. And he's also one of the heroes of the green movement. And in the middle of our recession, which hit us architects extremely hard, we asked him, like, you know, Professor Wilson, like, what are we going to do? All this biophilia stuff is great, but what are we going to do? What's the future? How are we going to actually solve the big problem? And he said that I believe we, as the developed world, need a new definition of success, one not based on the quantity of things that we have, but on the quality of life on Earth. So thank you very much. I appreciate your time.